Welcome back. This is the second lesson recording, actually third lesson recording, but the second one was of the Desmos activity. So third lesson recording for IM1, February 2nd, 2021. Now we are going to try a new puzzle. This time we have a triangle is equal in value to 3 circles. But I also know that circle plus 2 triangle is 14. So tell me in private chat, what do you think is the value of a triangle and what is the value of a circle? Okay, so it gets a little bit tricky, isn't it? Okay, so we have 3 circles is equal to 1 triangle. So how are we going to solve that? Well, we bring the one circle, the red circle, from just down like so. But we know that we're told from the first criteria or the first equation that each triangle is equal in value to 3 circles. So I can draw 3 circles and 3 circles here because I know that each of the circles are worth 3, each of the triangles are worth 3 circles. Then I have on the right hand side, I have plus is equal to 14. So now I have 1 circle, 7 circles is equal in value to 14. And from here, I can say that each of the circle is 2. And if each of the circle is 2, then the triangle is worth 6. Alright, so this is the new method, the substitution method. Let's break it apart. So when you have triangle is equal to 3 circles and circle plus 2 triangle is equal to 14, we can write the y is my triangle and the red circles are my x's. So y is equal to 3x, and on the second equation, that's the x plus how many y's do we have? 2 y's. The 2 triangles are 2 y's is equal to 14. So then from here, what I am doing is I know that each of the y we're told is same as 3x. So instead of y has the same value as 3x. So instead of writing y here, I can write 3x instead of y because we're told that y hat and 3x are same in value. So we can substitute when I see y to be 3x. But now look what happens. When I do that, all the variables that we're dealing with is just x variables. So we just have x variable and the number. So that means we can solve this. We no longer have x and y variable. We just have one of the variable. So we expand this out by 2 times 3x is 6x, or 6 circles in this case. And that gives us x plus 6x is 7x is equal to 14 on the right hand side. So divide both sides by 7 and you get x is equal to 2. And if x is equal to 2, then we know from the first criteria that each of the circles are equal in value to 2. So the triangle is going to be equal into 6. So y is going to be equal to 6. By substituting x is equal to 2 into this first equation, y is equal to 3 times 2, which is 6. So you're going to take notes again here. So substitution method, when do we use it? What are the steps? We use it when one equation has a variable isolated. So in this case, you have y is equal to something. Okay, y is equal to something. So that it's very easy to say that whenever I see a y in the second equation, instead of using y, I can substitute the expression 2x plus 1. So then you substitute the isolated variable into the second equation. So you should only have one variable now. So, and then the third step is to solve for the variable. Fourth is to use original equation to solve y2. Again, remember, we need to find the value for x as well as value for y. And then finally, write the solutions together, the value for x and value for y. So in this example, we know that y has the same value as 2x plus 1. That's what the equals tells us. So substituting that y into the second equation, whenever I see a y in the second equation, I am going to, instead of writing y, I am going to write the whole thing, okay? And when I write the whole thing, I don't want to just write it as it is. I want to not lose anything, so I put it in the parentheses. Because 3 is being multiplied to y. Okay, so this, remember, 3 is being multiplied to y, so I need to put a multiplication, or just the parenthesis would work as well. So this, the equation, after you substitute this 2x plus y 1 as the value for y whenever we see a y, then it forms this, and then you solve. Okay, when you see a parenthesis, how do we get rid of the parenthesis? With the number right in front. 3 is being multiplied, so we distribute by multiplying 3 to each of the term inside the parenthesis. 3 times 2x is 6x, 3 times 1 is positive 3. So 6x plus 3 is the result of this. We still have negative 2x from the beginning, and is equal to negative 13 on the other side. So then simplifying the left hand side, negative 2x plus 6x. They are like terms, so we can combine that to be 4x plus 3. The plus 3 just comes down here, is equal to negative 13. Now we don't want this plus 3 because we want the variable on one side, we want the number on the other side. So this is, we want to get rid of plus 3 by subtracting 3 from both sides. You're left with 4x is equal to negative 16. So divide both sides by 4 and you get x is negative 4. Now that I found my x, I need to use the original equation. You can use the easiest one would be the one that was isolated, because that's going to give you the y value really easily. X is in negative 4, so whenever you see a x in the equation, you are going to substitute it for negative 4, the solution that you just found for x. So y is equal to 2, negative 4, 2 multiplied by negative 4 plus 1. 2 multiplied by negative 4 is negative 8, plus 1, that's negative 7. And then, so we have figured out what is x value, negative 4, and the y value is negative 7. Great. So at this point, please take this down, pause the video, and copy any notes that you need. And then we're going to go on to the substitution method in the Desmos activity. Okay, so now we are using the substitution method. Let's try solving systems of equation using substitution method. We have two equations, y is equal to x plus 6 and 5x minus 3y is equal to negative 22. So we have two different criteria that we need to satisfy. So fill in the missing steps to find the solution. So it's same as previous equal value. You're just filling in what you're doing as well as the algebraic representation of that. Okay, so you have two equations, y is equal to x plus 6, 5x minus 3y is equal to negative 22. So y is isolated, so we are going to, whenever we see a y in the second equation, we're going to use x plus 6 instead. So we put a parenthesis instead of where y is, and you put x plus 3 wherever y is. So then apply distribution. That means what is being multiplied to the parenthesis? What's inside the parenthesis is being multiplied by not 3, but it's negative 3. So 5x stays the same. We haven't done anything to it, but we are multiplying negative 3 times x. That becomes negative 3x. Then negative 3 times positive 6 is going to be negative 18. Okay, and then you have just gotten rid of your parenthesis by using the distributive property, is equal to negative 22. So then next line, combine the like terms. What are the like terms we can combine? 5x and negative 3x. So that's going to be 2x minus 18 still remains because we haven't done anything to it yet, is equal to negative 22. And then add 18 to both sides. Why are we doing that? Because we want to have a variable on one side only. We don't want any variable plus or minus anything. So we want to get rid of addition and subtraction first. So we are going to add 18 to both sides. Okay, so when I do that, I am left with 2x on the left hand side of the equal sign, and on the right hand side negative 22 plus 18 is just going to be negative 4. Okay, so then we need to divide both sides by 2. So 2x gets divided by 2 and negative 4 gets divided by 2. Remember, whatever I do to one side of the equal sign, I need to do that same. So now you're left with x is equal to, what's negative 4 divided by 2? That's negative 2. Okay, so you figured out your value for x. X is negative 2, so now we can substitute it to the first equation. Okay, first equation is the one that was isolated for y. So instead, whenever I see an x, I am going to substitute negative 2. So I'm going to put negative 2 here. So y is now equivalent to negative 2 plus 6. And so y is equal to 4. And I'm done. Okay, now verify using the graphing method. So you just type in the two equations. So y is equal to x plus 6 and 5x minus 3y is equal to negative 22. Okay, somehow copying just copies these things that we don't want. And that's my error message. Okay, here we go. Alright, so then we have the solution. What is the coordinate? Negative 2 comma 4. So x is negative 2, y is positive 4. Is that what we said? X is negative 2 and y is positive 4. That's what we got. Cool. Alright, so now this time you're going to have to do this on your own. Okay, so all the system of equations substitution method. Let's try to solve another system. Solution is already provided for you. Fill in the missing steps. Okay, so what is the variable that we're going to substitute for? What is the variable that we have has been isolated? X has been isolated because you have x variable x is equal to with nothing else. X is equal to something else. Okay, that means on the second equation, whenever I see an x, I can use y plus 5 instead of x. So I am going to copy this equation and get rid of the copy mark. Alright, so whenever I see a x, because x has it has the same value as y plus 5. So I am going to put y plus 5. That's the value I have for x. X is always going to have the same value as y plus 5, and notice I'm putting it in parentheses so that I know that x is this whole thing. It's not just y, it's not just 5, but it's y plus 5. Then from here I know that, oh, so this is the second part. Okay, so here identify the isolated variable. It's x, isn't it? X is equal to, x is the variable that we've isolated. So I can actually rewrite the whole equation. Oops. Okay, then what are we going to do? We are going to distribute and then we're going to algebraically solve. Okay, I am running out of time, so I am going to let you finish. Okay, hopefully you are going to get y is equal to negative 1 and y is equal to 4 as your final solution. And the last card is asking you to drag the slider to show how confident you feel about today's work. Say more if you like. Okay, so you can, if you are totally confused, you've got this, or you're completely not unhappy. Okay, so please drag that. And then finally, we, as a closure, you're entering into table of content